Okay, this is the last section of Math 120, section 6.2. Okay, and if you look at that first sentence here, we are still just looking at trig equations, just some that involve the other trig functions, but can ultimately be boiled down to sine and cosine and using those, maybe tangent. All right, so the first little chunk here, as it says, is a bunch of reminders. All right, so, and these are ideas that we have been using in all of the other problems, just summarized nicely here. So, if you do a bunch of algebraic work, you move things around, you get down to sine x equals a number, sine of an angle, theta, whatever, equals some number, cosine equals a number, even tangent equals a number. Well, now we got to find solutions. All right, first question is, what quadrants are the solutions in? And all you're looking at there is the trig function you're using and whether that number is positive or negative. And we've been through that throughout the semester. Where is the sine function? Negative. Where is the tangent function? Positive. Stuff like that. Okay? So, now, step one, once you got quadrants nailed down, find the reference angle for your solutions. Now, that would mean taking this number and popping off the negative sign if there is one. So take the positive version of that number and do the inverse trig function. So inverse sine, inverse cosine, inverse tangent. And that will give you a nice angle in the first quadrant. So if you work in degrees, between 0 and 90, between 0 and pi over 2 if you're in radians. And that is the reference angle for all your solutions. Now, it might actually be one of the solutions if quadrant 1 is where one of your solutions is. But then, from question 1, the quadrants you selected for your solutions, find the angles with the reference angle from 2 that are in the quadrants from 1. And here's just those little formulas again. All right, if you're in quadrant 2, you do 180 minus the reference angle. It's 360 minus in quadrant 4, 180 plus the reference angle in quadrant 3. Okay, so the rest of reminders. The rest of the section is just examples. I'm going to do a couple by hand. We're going to look at some. I'll just show you the solutions rather than having to write out every last thing. And then there's group problems too, and you can work on those, and I will look over those in the video as well. All right. So, sticking to the first page, there's a couple examples that look like this. So, a cosecant function. What we ultimately are trying to do is get these guys boiled down to just something in terms of sine or cosine, maybe tangent. And so, like in the other situations, we're basically trying to solve for the variable theta, which means we need to isolate that trig function on its own first. So I'm going to add 7 to both sides. So we get 9 over there. And I'm going to divide both sides by 6. So 9 over 6, which is actually 3/2. And that's cosecant. And if we had a nice inverse cosecant function on the calculator, we could just use it, but most calculators don't. So what we got to remember is that cosecant is the reciprocal of sine. So if cosecant is 3/2, then its reciprocal equals the reciprocal of that. So sine theta would be 2/3. So now we're to that point where we have sine function equals a number. All right, so first off, what quadrants are we in? Where's the sine function positive? That's quadrant 1 and 2. What's our reference angle? Inverse sine of 2/3. We are working in degrees in this problem. And if you punch that out, you get 41.8 degrees. So then what are our solutions with that reference angle in quadrant 1 and 2? All right, well, theta equals, in quadrant 1, the reference angle is the angle. So there's our quadrant 1 angle. In quadrant 2, you do 180 minus the reference angle, which in this case would be 138.2 degrees. So there's your quadrant 2 solution. And there you go, 2 answers, one right there and one right there. Okay, so sometimes when there's another trig function involved, it's just a matter of getting it by itself and doing a reciprocal to turn it into a function that you're used to using. Now, this guy, a little messier. We've got 2 terms, one with secant, one with cosine. We do have a 0 on this side. And one convenient thing when there's a 0 is that you could just take this term and add it to the other side. So this is the same as 3 secant equals 4 cosine theta. We just add that whole guy to the other side. All right. Well, we're not going to get, we got 2 trig functions here. So now we're just going to use that tactic of let's just get sines and cosines involved. So secant is 1 over cosine, and this is already a cosine. So we could at least get the cosines on the same side. I'm going to multiply both sides by cosine. So that would cancel here and just leave a 3. And this would be 4 cosine times cosine, so cosine squared theta. If we divide both sides by 4, we're down to this. Now that's cosine squared, so if we're going to get cosine, we need to take a square root. So, square root of 3/4. But when you've got something squared and you take a square root to simplify that thing, well, you got to remember that this thing could be positive or negative, and when you square it, still get that number, so don't forget plus and minus right here. And in the end, well, you can't do much with the square root of 3 on top, but the square root of 4 is 2, so what we're actually looking at is this. We want cosine to be positive or negative this number, and that, of course, is one of our common trig values. And plus minus tells us all quadrants. Cosine is positive or negative in every quadrant. All right. Now, being a common trig value, you could just go look it up on your unit circle. Otherwise, if you do inverse cosine of that number, so ignoring sines and just doing positive version, you get 30 degrees. And so we're talking about angle from solutions are angles from all 4 quadrants with that reference angle. So theta ends up being 30 in quadrant 1, 150, 180 minus 30, 180 plus 30, and 360 minus 30. So here's your 1, 2, 3, 4 solutions from the 4 quadrants. There you go. Now, this part is nothing new. To some extent, even up to here, everything past this point was similar to previous problems. And the new part is having a secant involved and needing to manipulate some things. All right, so the other problems on the other pages, I am just going to look at a little more informally here instead. So here, we'll cover that. Okay. So, you see that? I kind of see that, okay. Oh, it's almost too dark. Ah, for Pete's sake. Okay, whatever. We can just have the whole thing on the screen and we'll go over it. All right, so here's our equation. You'll notice sines and cosines. And yeah, we prefer just one type of basic trig function. So what we make use of is a old trig identity, the fact that sine squared plus cosine squared equals 1, or rearrange the fact that sine squared is 1 minus cosine squared. So this sine squared, I'm just going to replace with what it's equal to. And then I'm going to distribute the 3, so 3 minus 3 cosine squared. And then we can combine 3 with -7, so that's where -4 comes from. And so we have -3 cosine squared plus 13 cosine minus 4. And the way we dealt with this before was to try and factor it, but to simplify the factoring, we introduced a letter. So here's the letter t, and we're going to let that represent cosine. So then this cosine squared is t squared, and this cosine is just t, and we're just trying to factor this guy. Okay. Now, when you factor quadratics, it's easier to handle it if this number in front is positive. So I'm going to multiply everything by a minus 1, which just changes the sign in here. So negative to positive and positive to negative and so on. 0 stays 0. And then we can factor this guy. And factoring is a matter of, well, what are our factors going to be? We can put a 3t here and a t here to get 3t squared. And then we just got to work out those numbers correctly so that if you were to use FOIL on this thing, the outers and the inners would give you the negative 13t in the middle, and it turns out that these two factors do that. So then we set each factor equal to 0 and solve for t. So we get down to t equals a third and t equals a fourth. Sorry, that's not a fourth, that's just 4. Now, if this was the problem we started with in algebra class, here we'd be done already. But we got to go back to where this all came from, and that's the fact that t is cosine theta. So we want to know what angles make cosine theta equal to a third and cosine theta equal to 4. But cosine theta is never going to be 4. We know that cosine and sine, for that matter, only give you numbers between minus 1 and 1. So this is impossible. That's a dead end. This, on the other hand, is not a dead end. This is a positive number, and cosine is positive in quadrants 1 and 4. If we do inverse cosine, we get a nice reference angle. And actually notice that this is not degrees. We're trying to find answers in radians. So I have this in radian mode. So here's your reference angle in radians in quadrant 1. So in quadrant 1, the reference angle is our solution. In quadrant 4, well, you do 360 minus the reference angle. Or in other words, in radians, 2 pi minus the reference angle. Now, you could, at this point, work everything in degrees and get your answers and convert them at the very end, and that would be fine too. But there's your reference angle, which is also a solution in radians. Here's your other one. There's your 2 answers. All right. Obviously, you can pause these videos, go back, look at things again, and so on and so forth at any time. Example 4, oops, kind of a similar deal. Now, we got a cosine, we got a secant. So like before, we dealt with a secant by just making it 1 over cosine. So that's what this first step is. Now we have cosine in a denominator, cosine not. So what we're going to do is multiply both sides by cosine. All right? Now that means multiplying all 3 terms, term, 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 by cosine. Now it cancels the cosine here, so we just have negative sign and a 1. 5 cosine times a cosine is cosine squared now, with a 5. And minus 6 times cosine looks like that. All right. Now, cosine squared to cosine and another term. We're going to add 1 to both sides, and, like we did before, let t be cosine. So now we have 5t squared minus 6t, and this guy plus 1 sitting there. That guy factors nicely into 5t and t, and then working out the numbers right to get these 2 factors. Set them each equal to 0, solve for t. And you get a fifth, and you get 1. Now, unlike the previous one, when we go back and use the fact that t came from cosine, put cosine back in for t, cosine x equals a fifth gives us solutions. Cosine x equals 1 also gets us a solution. All right, now this is a unique case. 1 is the biggest cosine can be, and that happens at 0 degrees, or 0 radians. And that's the only spot around the whole entire circle. So there's one solution, and that's just the end. We'll copy it down. For cosine equals a fifth, kind of the same deal as before. Well, that's these 2 quadrants. Do inverse cosine of that to get a reference angle in radians. Again, you could do it in degrees and convert to radians at the end. So one solution is in quadrant 1, it's the reference angle. And in quadrant 4, you do 2 pi minus the reference angle. And that gives us that. And so in the end, we have quadrant 1 solution, quadrant 4 solution, and this solution that came from this other equation. Ding, ding, ding. There they are. All right, now the other 2 pages are group exercises. So it would make some sense for you to stop and go try those out and see how they go, and maybe come back one at a time and see how they are. You can, of course, see the full written up solutions from the scan that's in Blackboard. But right now in this video, I'm just going to go back, and there's 5 of them. We'll just talk through them, and then that'll be it. All right, first problem. 3 secant equals 6. And meh, it's okay. This is pretty simple compared to the ones we were just doing. So secant is, again, 1 over cosine. So switch that up right away. Nope, that's not what I did in my first step. I divided both sides by 3 and just got secant by itself. Okay. So then if you switch it up, well, secant is 2. In the reciprocal of that is cosine, and the reciprocal of 2 is a half. And so now you're just asking, in radians, what angles have a cosine equal to 1/2? And you can look in the unit circle, you can do the reference angle stuff, or at least note, okay, we're talking about quadrant 1 and 4, and cosine is 1/2 for 60 degrees, and 360 minus 60 degrees, which would be 300, and that's these 2 guys in radians. And those actually came out nice, and typically you would just leave the answers like that. If you did punch them out, they would look like that. But when the answers come out nice, usually we leave them like so. All right, next guy. Do that and focus again. There we go. All right, just a nice plain cosecant. So get him by himself. Subtract 7 from both sides. That's where the negative 10 comes from. Divide both sides by 8. So negative 10 over 8 is negative 5 over 4. Or negative 1.25 if you want. That's cosecant though, so sine is its reciprocal. So if cosecant is minus 5/4, sine would be minus 4/5, or negative 0.8. So negative sine function, well, that's quadrant 3 and 4. So we'll take the minus sign away and do inverse sine to get the reference angle. And again, this is in radians, so that's reference angle in radians. So quadrant 3, that's, well, 180 plus the reference angle, but that's degrees, so radians, pi is 180. Pi plus the reference angle. Quadrant 4 is 2 pi minus the reference angle. That's what's happening here. Doink, doink, there's your answers. All right, last one on this page. We got a cosine, we got a secant. So 2 different ones, and like those previous ones, it makes sense just to turn secant into 1 over cosine. So in other words, this would be 9 over cosine, with the 9 there. Multiply both sides by cosine, and now all the cosine is right there. I also divided both sides by 25, which moved them down here. And to get cosine, you got to take a square root of both sides, but don't forget a plus minus there to get all the possibilities. This actually simplifies quite nicely to just a 3/5. And since we got the plus minus, we're talking about all 4 quadrants. So for the reference angle, just take the positive 3/5 and do inverse cosine. So there's your reference angle. And now it's a matter of finding the solutions in all 4 quadrants. So quadrant 1, it is the reference angle. Quadrants 2 and 3 come from adding and subtracting the reference angle from 180. 360 minus the reference angle for quadrant 4. And there's your actual answers. All right, 2 more problems. All right, cotangent and cosecant. Oh, you got that mix again. Well, yep, sometimes the best strategy is let's just go to sines and cosines. So cosecant is 1 over sine. So this would be 4 over sine when you switch it. Cotangent is cosine over sine. And this then is a nice setup where you've got the same denominator on both sides. So you could actually multiply both sides by sine x, and it just cancels them out altogether. All right, so multiply by sine x, cancel. Multiply by sine x, cancel, and you're left with 5 cosine x equals 4. So in other words, cosine is 4/5. And we're right back in that same situation. Well, positive cosine, that's quadrants 1 and 4. Inverse cosine for the reference angle. Now that's in radians. So in quadrant 1, that is our solution. Quadrant 4, we do 2 pi minus the reference angle. And there's your two answers. And the last one is similar to an earlier one. So we have cosine and sine. And to get that into just one trig function, write that as 1 minus sine squared. So that happens. Distribute the 2. Leaves us with this. Combine, 2 minus 2 actually cancels out. So all we have are these two terms. And so there will be some factoring involved here, but it'll actually be nice enough that we don't need to get the letter t going. You could if you wanted, but you don't have to. You can just see there's two terms. They both have a sine x in them, so I'm going to pull out a sine x. So from this term, we pulled out sine x, leaving us with one more, because this was sine squared. Taking sine x out of sine x leaves you with a 1. So factor, factor, set each one equal to 0. So sine x equals 0. This guy turns into sine x equals a half. So we're actually just dealing with sine x equals 0 and a half, which are two common trig values. Sine is 0 at 0 and 180. Remember, sine is the y-coordinate. Y-coordinate on the unit circle is 0 at 0 degrees and 180. Sine x equals a half happens at 30 degrees and 150 degrees, quadrants 1 and 2. And then just combine this. So we got the little fork in the road here. Both forks led to solutions, and we just wrap them all up in the end. And that's it. And that's the last video as well. So thus ends that.